So in our last session, we discussed about the busbar configuration system. So, and we concluded for our substation, for our project, we are implementing single bus with sectionalizer for 33 kV system and double bus with coupler for my 220 kV system. So this is the conclusion we arrived from last discussion. How you concluded? By doing the reliability analysis. This reliability analysis, I will talk in the next classes. So then I will ask you to implement the same for our project. Then you have to do the exercise and let me know what is the best uh, I mean the scheme you are developing on certain conditions like tariff and the PLF load factor, everything. Let's see that in the next classes. Meanwhile, let's come to here. So what we said, we are having a 33 kV feeders of 10 numbers, 1, 2, 3, 4, 5, and these are connecting to a bus. And this is connecting to a 33 bar 220 kV transformer. And this transformer and one more 5 number of 33 kV feeders. And these are connecting to a bus, and this is connecting to again a transformer of 100 MVA, and these 200 MVA transformers are connecting to the double bus bar configuration with coupler arrangement and 220 kV. So the configuration would results like this. And we decided have a 2 number of 220 kV lines that is going out from my substation, and to make it a uninterrupted bus change, we are having a bus coupler here. And now let's let's include the equipments also. So before going and adding the equipments everywhere, so let's talk about some important concept, that is the metering here. Come to the metering team. Generally, now you are exporting some X kilowatt hour means X units. Kilowatt hour is units, right? X units to the grid. So you are exporting X units to the grid. So if you are exporting X units to the grid, then he will pay for this X into, suppose each unit's cost is 2 rupees as per the agreement. He will pay certain amount to X of amount for you. This is the general way of doing. So where you are calculating this number of units. So for this, you have to place a tariff meter. A meter which we are implementing, which we are adding for the tariff to calculate the inflow and outflow of the active and reactive powers. Tariff metering. So the tariff metering, so how you are calculating the active power and reactive power? Obviously root 3 VI cos phi. So you would need two parameters. One is the voltage and current. So obviously you required a CT and a PT, right? A CT and with this PT. So these two outputs you are connecting to a meter. This is the current. This is the voltage. So these two are connected to a meter, which it is a tariff meter system. It's a metering system. So now power and the current and the voltage are connecting to a meter, and in this meter, the number of units will be recorded. So based on this number of units, the person will pay you money. So this again, suppose at sometimes maybe this will fail, or this is fail, or maybe this fail. So if you are failing this, then what will happen? So there is no accountability here, right? So one day the meter are failed, but you are exporting the power. So you are losing money, or you don't know how much power you sent. So for this, again, you need a spare, a standby meter system. Again, one more meter system. Same system, one more. which is connected in series to this side by side. This we will call as a main and check. Main and check metering. This is the standby metering. Always at every time, we are relay on the main and check. If it failed, then we will look at the standby. So it's a kind of a reliability again, the reliability. So this whole part will called as a metering. Metering. So this metering, in some projects, they will place in the lines, or some projects they are placing at the grid at the end at their substation end. Means this is their substation. In their substation, we are placing the meters. So when we are placing the meters in their substation, then what is happening? The losses are the losses which I am losing in the through the transmission line is in my scope. If I place the meters there, if I am placing the meters here, so the losses in the transmission line is bearing by the grid person. In the most of the cases, 80%, the meters will be at the grid end. So who will bear the losses? No one, right? So always the meters will be in their position, unless if some project specific. And in some conditions, generally you can place the meters here, or else instead of placing 2 meters, some will have like they will connect these both transformers, like these both transformers to a bus. Okay, and from this bus to meter, and now this meter is connecting to the double bus bar configuration. These are the 2 lines going out and a coupler. This is also one configuration. Instead of 2 meters, they are placing a single line, because so we don't know, because at sometimes this line is shut down. So the whole power is going through this line. So I have to place 4 meters here, main standby here and main and standby here. Instead of this, they will place only a main and standby at this location. And also, maybe sometimes this project of 200 megawatt is owned by 2 persons. 2 persons, maybe myself and my friend. So again, this is the total power on the basis the government or the private will pay a money to us. So apart from this, we will place 1 more meters inside here. So we will calculate here, and we will take the ratio of this, and we will share the rupees between us. We will share the rupees between us. So, and suppose in this 100, again, if there are partners of 5 members, each are having each developer 20 megawatt each, then each feeder you are having in meters. So it depends upon how the metering system is, means how many partners, or what is the business units, not only partner team. Suppose some cases what will happen is, at present, I constructed only this part of the substation. Okay, only this part of the substation. Okay, this was constructed. Actually, I am having a potential of 200 megawatt. But government, it's in 2015, government asked me to export only 100 megawatt of power in that financial year, for which they kept the tariff rating is 5 rupees. And in the 2018, the government given the clearances for again 100 megawatt of power, but the tariff for this project, for this part, is only 2 rupees. So only single owner. But again, to bifurcate, we have to show, okay, this is the number of units we exported with the 5 rupees tariff. These are the number of units we exported with 2 rupees tariff. So it depends upon the principle and the product also. Product in the sense, tariff product. How much power you are exporting. We are having different types of tariffs, like One example, a simple example is ABT meter, ABT availability based tariff, which is a present way of general, which present the government or the private sectors, mostly they are focusing on this type of tariff system. What is this tariff system? Let's see, have a go to the presentation. This is the ABT tariff system. There are generally, let's see from the from here. A tariff refers to amount of money the consumer has to pay for making the power available to them at their homes. There are different two types of tariff scheme. One, a consumer which they will pay to the discoms, and the other one is the discoms paying to the generating stations, means to us. We are the generating stations, wind, solar, water maybe. So we are selling the power to the discoms, and discoms distributing that power to the discoms means distribution companies. They're transmitting, they're sending the power to the households. So households paying to the discoms and discoms paying to us. This is how it goes. Let us discuss the tariff system existing in India for the discoms. Here, total this tariff system was regulating by Central Electrical Authority Commission, CERC. Central Electricity Regulatory Commission, which regulates this. Here, present in India, the availability type, the tariff system which adopting in the India is availability based tariff. As its name suggests, it is a tariff system which depends on the availability of the power. It's totally a frequency based tariff mechanism, which makes my power system more stable and reliable. Why? How? Let's see this mechanism of my ability system. Please listen carefully. Let's see. The generating stations commit a day ahead of the scheduled power, which they can provide to the RLDC, means Regional Load Dispatch Center. This RLDC conveys this information to various SLDCs, State Load Dispatch Centers, which in return collects the information from various state distribution companies about the load demand from various type of consumers. This SLDC, then the SLDC send load demand to the RLDC, and now RLDC allocate the power accordingly to the various states. If everything goes well, I mean, if the power demand is equal to the power supplied, the system is stable. Frequency 50 Hz. But practically, is it possible? Suppose I am telling that I am having 10 houses in my state. I am saying that for my 10 houses, they will switch on the lights only this day. So the load is only 5 megawatt. Now I conveyed it to the RLDC. Then RLDC conveying to the generating stations or the state and based on the power, it's giving the generating stations and telling, oh, this is the power I required. So if I am sending that power 5 megawatt, then it's quite good. But maybe out of the 10 houses, maybe one of the house having the function that day, or maybe one of the all the houses, maybe 2 or 3 houses are not in their town. They went out of the town and they are not using the electricity, so load will be down. So there could be some changes will be there. We cannot predict, right? Practically, it is not possible mostly. So one or more states overdraws or one or more generating stations under supplies. And these lead to the deviation in the frequency and system stability. If the demand is more than the supply frequency, that dips from the normal and vice versa. UI, utility charges or incentives provided or penalties imposed on the generating stations. I mean, if the frequency is less than the 50 Hz, implies demand is more than the supply. If the frequency, I have to monitor the frequency. And if I see If the frequency is less than 50 hertz, then I have to understood that, oh, the demand is more than the supply. Then at that time, the generating stations, which supplies more power to the system than the committed. I committed only 2 megawatt now, but now the load is asking, no, present I want 3 megawatt. Can you do that? Yes. If I do that, then I will get some incentives. I mean, generally, if my as per the agreement, for 2 megawatt of power, I am sending 2 megawatt of power. So for this 2 megawatt of power, they will give 2 rupees per kilowatt per unit generation. Now, if they're asking 3 megawatt, if I send 3 megawatt, then my tariff for the other 1 megawatt, they will take that 1 megawatt at the rate of 5 rupees or 6 rupees per unit incentives. On the other hand, similarly, if the frequency is less than above 50 hertz, it seems that the supply is more than the demand. Incentives are provided to the generating stations for backing up the generating power to maintain the system stable. See what I am doing here. Here, yesterday we talked about some projects like battery storage projects. This is the one of the idea that was came out from this. If I am having a more power, if the demand is less, then I am using that power for the storage. And other hand, if my generation is not there, but I have to demand is there, then I have to use this generating power at that time, so I can get the incentives. So based on this, the storage projects has came up. Usually, during the day period, the demand for power is very high, and the supply remains the same. Consumers are discouraged to use excess energy by making the cost high. We have to, this is the generally what now governments are doing. They are increasing the cost of the unit. Why? Because the demand of the power is very high. And nowadays, so to maintain the system stability or to maintain this, generally what they are doing, they are increasing the charges of the electricity. Contrary to that, during night time, demand is less compared to the supply. All will be in sleep. Okay. And hence consumers are encouraged to consume power by giving the free electricity or the cheaper rate for agriculture purposes. If you see the governments are giving, government will give free electricity, free supply during morning 4 a.m. to 3 a.m. for the farmers, for the cultivation, for whatever it may be. So that is because to maintain the system stable, all these are done to keep the power system stable. Clear team? Understood the concept of ABT, availability based tariff system?
Yeah, once again, regarding this frequency, can you please mention demand and supply, how the frequency will be differ? Can you please tell it again?
Where? I didn't get your point.
No. I think if demand is more and supply is less, then frequency will be less or more at the time.
Yes, sir. If you mean the frequency related to this?
Yeah,
Yes,
how
sir.
it will be related?
Yeah, if demand is more than the supply, suppose demand is having 5 megawatt, but my supply is only 3 megawatt. So in this case, it's asking the more power from my system, right? In this case, there could be chances of instead of this the active power, there could be a chances of taking means adding of this reactive power. So based on this, the frequency will be comes down. Means it will comes down. It will not be 50 edges. It would be like 49 edges, 44 edges, like that. And similarly, in the other hand, if my supply is more than the demand, I am sending for 5 megawatt, but the demand is only 2 megawatt, then the frequency will be very high.
Okay.
Yes.
Demand will be less, demand will be more than the frequency will be less. Okay.
Yes. Others, team, any doubts? Understood the concept of this? Okay. Let's come back to the. So this is the metering system generally applicable for the Indian products generally. Fine. So based on this, you can have this type of metering arrangement, like metering CD, PD, connecting to the main and check meters, and this is standby meter. It's a kind of a two or the different kind of a like reliability. If it fails, it will be there like that. So now back to the our SLD.
So I have only one few suggestion over here.
Yeah.
It's not a error, but you see here in the MTV main and check meter, no, it should be from the different core, but it is not clearly.
Yes. It is from different core only.
Yeah.
It is a single line representation, right? Only one core will be shown here. In this CD, if you make it, if you just zoom it, or if you check into the deep in this, so this CD is having 3 or 4 cores. So one core is going to this one core, but in a simple way showing.
Okay.
Yes. Yes. Come to the fine. And one thing, please check here. These are the different types of symbols used for the substation team. And I'm not only, this is not the standard. You can use the symbols as per the utility standards or the as per the IEEE or IEEE, whatever it may be. So it's you have to comply to the standards or the utility guidelines where you are developing this project. So this is will be taken care by the draft person. Okay. This is the breaker, lightning arrestor, isolator with a switch, isolators which are motorized and gang operated isolators. This is the capacitive voltage transformer. As I forgot to explain you, I will clear you this. This is the potential transformers, and this is a current transformer, CTs, transformer, bushing CTs, and neutral current transformers. These are general symbols. And now there are some ANSI codes here. Forget about this ANSI codes. This we will see in the next classes about the relays. For present, we are having the equipments. Lightning arrestor is an equipment which will not come for the controlling part. It's a just equipment. Come to the CT and PT, these are the measuring ones, measuring equipments. But come to the breaker, isolator, and the edge switches, these are controlling equipments. Means which we have to open or close during the maintenance or during the faults. So for this, we are having the ANSI codes. The breaker ANSI code is 52. Isolator, the ANSI code is 89. And for the edge switch, the ANSI code is 57. These are the ANSI codes for the 3 equipments. Remaining, you will just include the CT, PT, LA, transformer. These are the only 3 equipments which required, apart from the relays. because we are only focusing on the equipments. That's why these are the three equipments which require the ANSI codes. I mean, let's see this in this way.